So we've walked up a bit of the way and we have the incredible McDonnell-Douglas F-4 Phantom, which flew with everybody, served with everybody, is still flying in some places, and was the next thing that McDonnell did, wasn't it? So let's get into some of these lessons that we went from our uninteresting aircraft to arguably one of our most favorite. So off you go, Joe.
Yeah, so the F-4 is, I mean, on our last video we were talking just about the Century series. This really is what came out of the Century series. In configuration, a lot of details, it's not that much different than an F-101. Similar weight airplane, if I remember right. It's probably slightly heavier, but not a lot. Similar size, 2 seats. Actually, it's got similar engines. This uses a J79, the F-101 used a J57. These were later versions of J79, so these do have a lot more power. But at the time, the J79 and the J57 were contemporary engines. So, you know, it's not a vastly different engine setup. Probably the biggest difference is, one is the inlets. So this was in the full-on variable inlet stage where you've got movable ramps, boundary layer bleed on the ramps, a flight control computer that would adjust those automatically. And because of that, the airplane would fly much faster. So this was, a Mach 2 airplane. I don't remember how fast it goes. I think it's Mach 2 plus, but very fast airplane.
So I guess the most noticeable bit is the engines are more embedded into the airframe as opposed to just sat up on top of it on the F-101.
Yeah.
So we can get into a lot of the more interesting things that we've been talking about on the Century series when it comes to wings, tails, and the like there. The packaging makes more sense on this aircraft.
Yeah, so this airplane very much was of the era where area ruling was understood. And there's not much Coke bottling going on here per se, but if you look at the overall plan form, the shape of the nose, the inlets, I think is most evident in the back where the fuselage kind of necks down behind the engines. This was a much more intentional design on that front, which meant lower supersonic drag and the ability to go faster in addition to the engine inlets. The other curious thing about this airplane is it kind of in a way was the reverse of the F-101. So the F-101 started out, again, as we said, as a bomber escort with guns. Then at some point it switched to on the B where the guns went away and they put on missiles. This airplane was originally designed without a gun. I think it was one of the first fighters that was designed of, we don't need guns anymore. We've got these fancy missiles, they work great, we don't need guns. Most of the F-4s do have guns because then they figured out that the missiles weren't nearly as reliable as they'd hoped. You get in a close fight and you're screwed. There's nothing you have left. So a lot of these airplanes, most of them did have guns that were put back in later. The other probably biggest difference of this airplane is the wing. This thing really was made for maneuverability in the way that the F-101 was not. So it's a much larger wing.
Let's get down and have a look at it.
Look at that more closely. This aircraft really was designed for turning hard, and so there's features here, and I think this is a later model. I don't remember what model this is. I don't think the original aircraft had this, but you can see this wing slat that basically has a slot here, so at really high angles of attack, turning really hard, the airflow that wants to separate out here can actually flow through this slot. It can re-energize the airflow above and basically can turn harder without this outboard wing separating, which was the exact problem with the F-101 that led to the pitch-up problem. So obviously this is pretty crude. There's a lot of drag that comes out of this, but when you have enough of the rest of the aircraft that's reasonably efficient, nice inlets, big engines with a lot of thrust, you can afford things like this, and if it makes your maneuverability much better, it's a good trade.
So that's why it's got the sawtooth.
Yeah, and the sawtooth is the same thing. So right here, when you get a big notch like this, what'll happen is when the air flows up through here, when it hits this, basically this sharp angle here, it goes up into a really tight vortex that flows back. This fence here is to help kind of keep that flowing back as a flowing outboard, and that vortex forms kind of like a reset. So any airflow that's trying to flow out gets sucked into that vortex and doesn't go out and affect the rest of it. So the leading edge strake like this is really good at doing that.
So this is a big and sort of industrial version of the little vortices generators you'd see on the other Century aircraft.
Yeah. Yep. Another curious thing about this airplane that I think makes it look really cool, I love the aesthetics of this airplane. We'll talk about the tail in a moment, but I mention it for the moment because notice the downward cant of the tail, and then you have the upward cant of this outer wingtip. There's something to me about the juxtaposition of those two that just makes it look so iconic. So, though I understand it, this airplane originally had a straight, no dihedral wing, or maybe slight anhedral, meaning bent down. This bending up was not here. I believe in early flight tests, and I don't remember if this was on the prototype or if it came in on in an early production model, they figured out the airplane needed a little more dihedral. And dihedral on an airplane helps its stability. It helps when you start to get sideways or start to go into a yaw, it helps the airplane naturally correct itself and fly straight. If you don't have enough, the airplane doesn't want to fly straight. It wants to go off and turn and whatever. So it's more pilot workload.
Which is why on civilian aircraft we see
a lot of dihedral.
Yeah.
Yep. Jets typically have less dihedral because they have so much wing sweep. And sweep itself has what's called dihedral effect. It does the same thing. So this airplane, when they first flew it, they figured out it doesn't have enough dihedral. Unfortunately, dihedral is hard to fix. You kind of have to design a whole new wing, not a whole new wing, but all of your center structure has to be redesigned because it now needs basically a bend in it. And so one of the tricks designers will play is if they need just a little bit, you don't have to rebend the whole wing, you can just bend the wing tip. And this thing already had a joint out here, and if I remember right, the Navy version of this even had folding wing tips. So it was like a no-brainer just to reset this at a slightly different angle, a few different bits down here, and you're done. And so, from what I understand, that's why this thing has that break and has the dihedral out here, but not the entire wing. And again, I know it's there for practical reasons, I just think it looks cool. And
it
it's
looks
so
fantastic.
iconic.
Yeah, it makes it look meaner.
Yeah,
it's already a very, a fighter should look a little bit mean and a little bit pretty. And the F-4 is a little bit mean and very pretty.
Yeah.
Right, so now this is my favorite F-4 fact, of course, which is on American built F-4s, you do have our Coke bottle sloping in on the back. You shove a couple Rolls-Royce Avons in the RAF and the Royal Navy versions. There ain't none of that, dear listener. It's just absolutely straight. So I think the gag was in a straight sprint, the Royal Navy version was quicker, but over a distance,
thrust, right?
This would take it because it had a higher top speed.
Yeah. Yep.
We're going to do a full thing on the F-4, but this is a special treat for everybody who has pointed out that while the F-110 here technically is Century, it's not really, and more importantly, this is the beginning of the fighters that we would see all the way up until now, really.
Yeah.
So let's get over here and have a look at this.
Yeah, so we talked about the tail. On the F-101, remember, the tail started in the low position, but it had no anhedral like this one, it was straight. On the XF-88, that was true. On the F-101, they moved it up to the top. On this one, they basically knew of the deep stall and the T-tail problems, so they basically moved the tail back down, but to solve the problem of it still like being too high, they essentially canted it down to get at least the tip of it kind of more where you wanted it. And the only downside of this is when this tail goes fully down, it is in the exhaust flow of the jet engine, or like right on the edges of it. And I don't know the full details there. I believe this is titanium, so it could withstand the heat. Actually, it might even be stainless steel, not sure which, but I think it could withstand that heat. And I'm not sure if when this thing's in full afterburner, what the limits are there, if it could actually get in that flow, because I can't imagine even with those materials it would last very long. But they obviously solved that problem. So kind of a unique, different way of approaching that than what they did before. And again, it was same designer, same people, same company, and just learning from what they did before, what they wanted to do better when they went off to do a new aircraft.
The old adage of if it looks right, it goes right. There are so many elements on this aircraft that just look right. And the length of service it's had has been, we talked about how the Century series would see sort of well into the 80s and well into guard service and things like that. But the F-4 adapted, fettled, updated, new avionics, new weapons, the guns coming in the late 60s.
Yeah.
I'm going to make there we go, hold on a second, let's turn this around. Right, you've got to look at me for this one, because this is my statement, this isn't Joe's. I think this may be the perfect fighter.
I won't argue with you.
Yeah, there we go. We've got Jose. So I put it on me just in case he did complain. But for what this aircraft and its service has done, and we will be covering this in depth in the future. For me, F-4, perfect fighter. It's done everything, did everything, flew with everybody, including some people that we don't quite like anymore. But yeah, that's another story in and of itself. But amazing fighter. But we'll get back to Joe now. So I've made my bold statement, which my friend has backed me up on. So that's great. So you see, we've gone back to my friend, and he's still happy with me as well. So there we go.
And I've got a disclaimer. I'm slightly biased on this aircraft, this one particularly. So my dad in the mid-'60s actually worked at McDonnell Aircraft as an electrical technician. He sat in the cockpits for a year or two of F-4s, installing and doing quality checks on avionics. And he was at this museum about a year ago with me, and we figured out on the date code on the tail, there's a high likelihood he sat in this exact airplane and helped build this. So yes, I've always thought the F-4 is cool, partially because of that, partially because it just is cool. So we're on the same page on this one, Matt.
But there we go. So welding family connection on this particular airframe as well. So we've been stood at the back of the aircraft for a little while, and of course it is, if we look up here, an Air Force tail number. But there may be some people going, hang on a second, that's a tail hook.
Right.
Joe, so why do we have a tail hook on an Air Force F-4?
So the way I understand this, and I'm no expert on this, I do know this airplane was originally designed for the Navy. So this was originally a Navy fighter. In fact, should have started with this. This is probably one of the most successful multi-service fighters ever built. Usually that story does not play out well, right? But this one, the Navy used it for a long time, Air Force even longer.
See our episode of Bill Sweetman about a current multi-service airplane.
Exactly, or the F-111. We won't talk about that. But anyway, so originally designed as a Navy aircraft, so it had a tail hook designed into it from the beginning. Not all Air Force aircraft have tail hooks. Obviously, they're not landing on carriers. Some of them do, and the way I understand this, what was told to me is a lot of Air Force bases will put arresting wires at the end of their runways as sort of a final safety net, so to speak. If the drag chutes on these that most of them use for landing failed, they could basically put the tail hook down, catch those arresting wires at the end of the runway, and save the airplane, save the pilot. Mm-hmm. So, especially in a case like this where it's already designed into the airplane, it's kind of a no-brainer. I believe F-15s have these as well, I think. Even though I think so. Don't quote me on that, but I think they do for that exact same reason. A lot of Air Force airplanes don't, but some do.
And how hefty is that? There is a lot of very, very sturdy.
Oh, and this is all titanium and no paint, notice, because I'm standing, I'd be Thanksgiving dinner here in about half a second if this thing was taking off. So imagine, the back of the engine is right here. This thing's shooting afterburner flames out, I don't know, 20 feet or something. Massively hot radiant heat, even though they don't directly impinge on this, just that radiant heat. Think of standing in front of a fire in the wintertime where you can just feel it from 10 feet away. If there was paint on here, if this was aluminum, this would all essentially melt. So the other thing is this gets so hot, these things expand. You can see the size of these washers. All these panels move when this gets hot, and those big washers. So underneath that washer is going to be a very large hole, so this thing can stretch and move, and that washer holds it in place. So very common feature. Anytime you have aircraft structure this close to an afterburner exhaust. Yeah.
And of course the variable whatchamajiggy is not on this side, because we come around to the side that people can't see. But there she is.
Yeah, the variable engine nozzle.
Nozzle, that's the word I'm looking for.
Nozzle. Some people informally will call these turkey feathers because this diameter changes at different flight conditions to get the optimum area, and these little pieces overlap, and that's kind of the slang term of that is called turkey feathers.
So we've looked at all of the aircraft in some detail now, and I guess we've sort of briefly said that the F-4 is all the lessons learned from that. I guess the next part of the story would be the lessons learned from the F-4. We mentioned that it didn't have a gun initially. It was a good dogfighter, not a great dogfighter,
right?
Which leads us to the fighter mafia, which is a whole other story we're going to have to cover a bit later, because for all the wonderfulness of the F-15 and the F-16, there were some nuts ideas on those planes, like no missiles whatsoever, no radar. It was pure dogfighting.
Yeah.
But I guess from the experience in Vietnam with this aircraft, and what we could do, because there are lines on this that are quite familiar with a new addition to the Wings Over the Rocky Museum down on the end, because I'm looking at the tail, and a certain company in Russia built an airplane that has a very similar tail to this, and I'm putting you on the spot for that, but there is a MiG-23 here, so we should...
Similar time frame as well, I believe.
We should pop down and just wrap this up by having a little look at the MiG.
Yeah, let's do it.
Okay, dear listener and viewer, and wherever you're watching this, we've come over just to have a quick look at the MiG-23, which, to be fair, is right by the windows, so you might be getting a bit of shadow on this. This is very much us just coming around and having a look at it, because it's a contemporary of a lot of the aircraft we've been discussing, and many, many things that are similar on it. Let's just head up to the front and away from the telly telling the story about it, because a lot of the same problems faced, many of the same solutions taken, but a few things that are a little bit different.
Yeah, so first of all, this is a swing wing fighter, which I don't know as much about this airplane, so I apologize. I don't know the exact timing on it. I think this was one of the first, might have been the first, I'm not sure, other than research aircraft. Very early, you can see that feature here. So there's a pivot point right here. There's a very large pin, and then this whole wing, swings out. It's in the swept position at the moment. The advantage here, so this is what's called a variogeometry wing. It's kind of the best of both worlds. There's some downsides as well, which we can get into in a minute. But the best of both worlds aerodynamically is when you're going fast, you don't want a lot of wingspan. You want your wings tucked back, really sharp leading edge or really swept leading edge. So it's great for high-speed flight. So much like the F-102 with the delta wing when it's in this configuration. When you're flying slow, either for landing or for maneuvering at lower speeds, you actually want a lot of wingspan, because more wingspan is a bigger volume of air that you can use to create lift, and so it's more efficient, it's more stable, the wing likes to fly better in that condition, everything else. So anything you're doing slow, you want a lot of wingspan. And so by swinging this out, you get the best of both worlds. The downside of it is complicated, so you can actually see there's plastic's been put in place here. You can see some of the details in here. So like here's a fuel line, for instance. So this outer wing has fuel in it that you've got to get through this rotating joint. So all these parts, move. There's a big actuator here is what actually brings that in and out. Massively large actuator. I can't imagine how much force it takes to move that in supersonic flight. And then you can see things like these lines, I think they're probably hydraulic lines for the control cables and so forth. All of that's got to move through all this as well. And then probably the biggest problem is the structural problem. So all of the load in this wing, most airplanes have these nice wing spars, these beams inside the wing that go kind of across the fuselage and carry all the load. All of the load in this wing is being reacted through this pin right here. And so the buildup, you can kind of see the size of some of these metal pieces and all these rivets and screws and everything, like all of this whole wing has to converge down to this one little point. And this is a fighter, this is not an airliner that's cruising around at 1G. This thing's probably pulling 9 Gs or whatever, and all of that lift to lift this entire airplane is going through that pin. And so I think generally a swing wing adds something like 10% to the weight of the whole airplane, and 10% weight hit is massive. But it's traded off by the great advantages of aerodynamics. So for a long time in the 60s and early 70s, it was thought that this is the best version of a fighter. And it's not a terrible version, but it hasn't won out, in time.
So again, that weight problem starts negating a lot of the advantages of it.
Yeah. The weight and the complexity, both. Yep.
So there we go. We thought we'd just come over and have a look, because this is a new addition to the museum here at Wings Over the Rockies, and it's
2D variable inlet, much like the F-4.
There's a lot of chiming design features on it, isn't there? So it's something. I do, again, looking right at things like that, you can tell easily it's Russian, but MiG really did design some pretty looking, rather industrial aircraft.
Yeah. And if you ever have a doubt if it's Russian, look at the paint inside the cockpit. it's always that kind of turquoise blue. I don't know why. I actually kind of am fond of it, but like every Russian airplane has that same color, including the Tu-144, their supersonic transport, is that exact same color in the cockpit.
Here we go. So hopefully the sun, which is absolutely brilliant today, will show this. But yeah, here we go. It's almost a teal, isn't it?
Yeah, yeah. Very distinctive.
Yeah. Well, there we go. So if I spin this around this way, because we don't want to look over my left shoulder too much, we've got a lovely view. Oh, there we go. I've just spoiled it. We'll be talking about that later. But there we go. Here's the wings of the Rockies Museum, and that is their Century Series aircraft. If I point this down at Joe, final thoughts on the F-101?
Very interesting.
Yes! There we go. You see, we've held this all off for a specific video when we've come up to Denver, when the snow has just about melted. So there we go. Thank you very much, dear viewer, listener. Do the like and subscribe, and we will return when we discuss the B-1A. I just want to say many thanks to our fabulous Damcasteers on Patreon. If you head over to our Patreon page, you can join the crew and get your name in the credits from just £3 a month plus a bit of that. The Damcasters is hosted and produced by Matt Bone and is a Boney Abroad podcast production.